So in our lesson today, even though the book does some more of those hyperbolas and lines, since we are doing all of those on the graphing calculator to find the intersection points, there isn't anything different. The book's doing it algebraically, so there's a little bit of a difference in what they end up with. But for us, it's plot the y equals a number over x, plot points, draw the hyperbola branches, graph y equals mx plus b, punch it in on the calculator, and find the two intersection points. So what we will talk about today is the other topic of lesson 96, more on variation, specifically joint and combined variation. We have already had direct and inverse variation. So this is just taking it one step farther. We know that anytime we have y varies, we start off with y equals k. And then we have already learned if it says y varies as or y varies directly as, we put that variable in the numerator along with a k. If it says it varies inversely, we put that in the denominator. The only part that's different is they may say today it varies jointly as a and b. And then we'd put y equals k, and we'd have a times b up here in the numerator. If it's joint, we'll put them both in the numerator. Or maybe it says it varies directly as c and inversely as d. So it says two of them in that way. And so then we put the direct one in the numerator and the inverse one in the denominator. So we're going to have, besides the y equals k, we're going to have two or more variables that we plug in for into the formula. And that's the only difference in what we're seeing today. So one of my examples on that, strawberries vary jointly as plums and tomatoes. So I start off writing strawberries vary, so S equals K. Where did I just say jointly goes? Point up or down for numerator or denominator. So numerator, so that means both of them go in the numerator, plums and tomatoes, and we multiply all three of those. And that's all they give us for this one. Read it carefully. Was anything squared? Did it vary as plums squared or tomatoes cubed? Always check that you're reading it carefully. We don't need any exponents or square roots. So then we plug in for case one, 500 strawberries, 4 plums, 25 tomatoes, plug them in wherever they land in the formula. What do we have to do to get k by itself? Divide by 100 and get. So for that one, since 4 times 25 is 100, we divide by 100 to have just k. Divide this side by 100, and we know k is 5. Then write down what that means our formula really is. It is really S equals 5, pt. Then we move to case 2 and plug in wherever we have them. Maybe S is the one we need to find. Maybe it's one of the others. Doesn't matter. So we want to know how many plums go with 40 strawberries and 2 tomatoes. So you guys go ahead and find P in there. We have 5 times P times 2. So figure out what we have to divide by, divide both sides by that, and we will have our number of plums. And hopefully we are just about finished working our way through that. Austin, what'd you get? Anybody else 4? So again, the 5 times 2 is 10, divide both sides by that, and P is 4, and we label it plums. Easy enough, right? Okay, one more of these. Number of elk vary inversely as number of deer and directly as the number of antelope. So this is combined because we have it varying as this and as that. So at least 2 different things in there. So we are going to write down elk varies, so E equals K. Everybody point, where do I put the deer? It varies inversely as the deer. So everybody's pointing down, so in the denominator for the deer. Directly as the antelope, where do I put the A for antelope? Numerator. Plug in case 1 that we know, 75, K. The deer, that was my denominator. And then my antelope, that was the A, so that goes in the numerator. So I have 15 over 85 times K equals 75. What do I multiply to get just K, Kit? So multiply both sides by the 85 over 15, and we'll have K. You may do 85 times 75 over 15 on your calculator, or you can reduce the 75 over 15 first, and then multiply that by 85, whichever way you prefer. And so I'd like you to go ahead and do that, and then you can tell me what you have come up with for K for this problem. Ethan, what'd you get? Thumbs up, thumbs down for 425. So then let's write down what our real formula is. E is 425 A over D. And again, always make sure we didn't have anything that was squared or the square root of or anything like that in the problem when you first start it. Now for case 2, how many deer were there when there were 20 elk and 30 antelopes? So we plug them in, whichever one we know, we plug it in wherever that variable happens to be. So 20 elk, that goes over here. Keep the 425. 30 antelope, that's the A. So the D that I need is in the denominator. Who remembers what I do to get D by itself now? What does that motion mean, Wyatt? Swap what? So you take the diagonal and you can swap the things that are on one of the diagonals. So D is 425 times 30 over 20, and enter that however you would like on your calculator. However, it's not going to make a whole lot of sense to me if I have an improper fraction. So put a decimal in after any one of your numbers in that so that it won't give us that improper fraction. Because my brain just doesn't know what 1,000 and something over 2 is without doing some work to convert it. So Abby, do you have our number of deer yet? Yeah. That's what I'm saying. It would have been an improper fraction. And to my brain, 637 and something makes a whole lot more sense than 1,300 and something over 2 would. Now, I know it does not make any sense to have half of a deer, but go ahead and write it down with a decimal so I'll know that you did the work correctly. If it asks you to interpret in some other way on the question, then you could decide whether it makes more sense to round it up or to truncate it and round it down. Does that much make sense to everybody? Right. One other thing I want to go over with you before we start working on homework. Nothing really to do with this lesson. It's some more out of 94. But there's going to be one kind coming up that you haven't quite seen before, and I want you to have an example of how to deal with that. It's function notation. So this one is review, so I would like for you to go ahead and evaluate what is g of -2. That says we're going to define this for any x that's a real number, put that real number in for x in 2x minus 7, and that's what g of -2 will be. And this much is review. Ada, what'd you get? Anybody else -11? Sounds good to me. We put that -2 in for the x, and then we subtracted 7. So -4 minus 7 was -11. So again, this says if it is a real number, put that real number in for the x, and here's how we define g of x. Next one is a little bit different. P of x is x squared. Find p of a half. It says that is defined for any x that is an integer. So that's enough time to be done with this one. Who can tell me why that's enough time to be finished with this one? Why does that one go quickly? Let me say that again. This says we define p of x to be equal to x squared for any integer that we want to put in there. Why is there actually no calculating to do on this one? I'd like to see more than one hand up. What is the problem here? That rule is defined for integers. Nicole? Exactly. 1/2 is not an integer, so this is undefined because a half is not an integer. And you're going to start seeing a few of these in homework problems. Does that much make sense? Okay, in a moment, I'm going to have you guys work on 2 and 6 for me to stamp.